Welcome to Fluid Mechanics N6. Today's presentation is going to be on centrifugal pumps. We did a video on reciprocating pumps, but we couldn't include centrifugal pumps in the same video simply because we did not want to make it too long. And so for that reason, centrifugal pumps is presented separately, and this is what we are doing today. I do want to say that if you haven't watched the video on reciprocating pumps, I strongly advise you to do that, because I will assume that some of the basic principles which are introduced in that video are things that you already understand. So in this video, I am only going to build from that, because remember, both reciprocating and centrifugal pumps are in the same module. They're all part of the same module in the textbook. And so I am not going to start over from the beginning, but I will just build up from what we already did in the reciprocating pumps video, and I will introduce centrifugal pumps. So let's begin. First, we will speak of the working principle of a centrifugal pump. Already, when you hear the adjective centrifugal, this should remind you of the centrifugal force. And the centrifugal force is a force that is acting on anything that is going around a curve, okay? Anything that is moving in circles or that is moving in such a way that it goes around a curve with a certain radius of curvature. Anything that is moving like that will experience a centrifugal force acting on it, okay? So, and the centrifugal force acts from the center of curvature and outwardly. So for instance, if something is moving around in circles, the centrifugal force will act from the center of that circle, and it will act on the object, and it will act outwardly, okay? It will act away from the center of the circle. And that is one of the reasons vehicles that go around curves very fast end up turning over, okay? The reason for that is because there is a centrifugal force that acts on anything that goes around a curve. And if you move very fast, then that force increases also dramatically. And that's what causes objects to move away from the center. And in the case of a vehicle, it can cause it to overturn, okay? So that is all the centrifugal force. That's why when you are coming and moving around the curve, they will usually tell you to slow down. It's to minimize the effect of the centrifugal force on the vehicle, okay? And so what is really key to understand is that the centrifugal force is acting from the center of rotation and away from it, okay? So the object will have that force acting away from the center of rotation, but its direction is from the center of rotation to the center of gravity of the object, but away from the center of rotation. I hope this is making sense. And so what you are looking at on the screen right now is a centrifugal pump, and it is connected to a motor. So what you see here is the centrifugal pump, and it is connected to a motor. And so the way it works is water will come in this way, or whatever fluid you're using, it will come in this way and it will be discharged in that direction. So the suction pipe will be connected here, and the discharge pipe will be connected there, okay? And so this motor, of course, is spinning the impeller inside of the centrifugal pump, and in this case it's gonna be spinning anti-clockwise so that it can discharge the water in that direction. And so if we look at the inside of a centrifugal pump, this is more or less what you expect to see. You can see the suction pipe here, and you have the fluid that is coming in this direction, and this impeller is connected to a motor, and it is being caused to rotate anti-clockwise. And as it rotates anti-clockwise, the fluid that has been sucked in will then be driven in that direction and out through the discharge pipe. So the first thing that happens when it comes to the working of a centrifugal pump is that you have the motor spinning the impeller. Okay, the impeller is pretty much this set of blades that you see here, and at the center of the impeller, that point that you see there, this is what we will refer to as the impeller's eye. Okay, and so the motor will spin the impeller, in this case in the anti-clockwise direction. As it does that, because the water is spinning, what will happen is that centrifugal forces will act on the water. Okay, and these centrifugal forces will cause the water to move away from the impeller's eye, or from the center of the impeller, and so the water will come and pretty much stick to the walls of this centrifugal pump. Okay, and the inside there will have a vacuum that will form. Okay, and when the vacuum forms in the center there, a vacuum is pretty much a place of low pressure. That will then cause the atmospheric pressure that is acting on the water that is maybe in the tank to then push more of that water inside of the centrifugal pump. And when that water comes inside of the centrifugal pump, because the impeller is rotating anti-clockwise, the centrifugal forces that are acting on the water that's rotating will again push that water away from the center and again create a vacuum. And then the atmospheric pressure will then find itself forced to push again more water inside of the pump. And then the impeller, which is rotating, will again through centrifugal forces push that water again away from the center. And when it moves away from the center, and then because we are rotating anti-clockwise, it then of course goes out. And that process can continue forever, as long as you have a motor that is working and a tank that is providing water. And that is what makes centrifugal pumps quite useful. And so some of the advantages of using centrifugal pumps over reciprocating pumps is, first of all, because they are not expensive to operate, they are not expensive to maintain, and also even the buying price of a centrifugal pump is cheaper, okay, for the same application than that of a reciprocating pump. So in terms of costs, centrifugal pumps are your best option. And two, they are compact and efficient. Okay, the ground space that you need for a centrifugal pump is much less than the space that you will need for you to install a reciprocating pump. And as you can see, centrifugal pumps do not have complicated parts. Okay, you don't see valves here, you don't see pistons here. You pretty much just have an impeller that can be directly connected to the motor, because you don't even need to have a gearbox in between. That impeller can survive the fast speed of rotation from the motor. Okay, and because of all these reasons, centrifugal pumps are generally preferred over reciprocating pumps. In most cases, when you have a pump that is pumping water or some other fluid, it's most likely a centrifugal pump. All right, very important. Moving on, we will look now at the velocity diagram. If you've done power machines N5 and N6, the concept of velocity diagrams shouldn't be completely unfamiliar to you. You've seen that when you're dealing with a velocity diagram, we are trying to represent the velocities on a blade, and in this case it's going to be a vane. Okay, and we will represent the inlet velocities and we will represent the outlet velocities by means of a triangle. Okay, so, or should I say triangles, okay, one for the inlet scenario and one for the outlet scenario. And so what you're looking at on the screen here is a vane. Okay, this is the vane, what you see here, and it is moving in that direction, anti-clockwise. And that's the direction in which the vane is moving. And so the triangle that you see at the bottom here, this is what we will refer to as the inlet triangle. And of course, we will label it like this. everything you see in this triangle is a velocity, and we use the subscript I because it's the inlet triangle, so all of these are inlet velocities. The angle here is alpha, and we will very soon see what everything is in the triangle. So alpha is the inlet angle of the impeller guide vane. Okay, so in this case, the inlet angle of the impeller guide vane. UI here is the peripheral speed of vane tips of the impeller. Okay, VI is the absolute flow velocity of the water, and VRI is the relative flow velocity of the water. So the absolute flow velocity of the water is measured with respect to the pump itself, okay? But the relative flow velocity is measured with respect to the moving vane, okay? So that is very, very important to understand. And so usually when they will, if ever you get a question and they've drawn for you a velocity diagram, sometimes they may put the labels there for you to just be able to maybe do some calculations. But at other times they could maybe put the numbers, and it's going to be for up to you to establish which is which. For instance, if they write here 5 meters per second, then you will know, because it's written there, this is the absolute flow velocity of the water. So you need to familiarize yourself with how this looks, because it can be important for you to know that for the sake of resolving a problem in this particular module. And so this here is the inlet triangle, and what you see on top there is the outlet triangle. And again, here we also have labels for each of these velocities, and of course we also have two angles here. And so if you wish to know what is what, theta that you see here, this angle, is the inlet angle of the impeller guide vanes. Phi that you see is the outlet angle of the impeller guide vanes, okay? And then you also have UO, okay? You can see every velocity has a subscript O. This is just to say outlet, because it's the outlet triangle. These are velocities on the outlet triangle. And so UO is the peripheral speed of the vane tips of the impeller. And then VO here is the absolute flow velocity of the water. VRO is the relative flow velocity of the water. One that is quite important is VFO. This is the radial component of the absolute flow velocity. And VWO is also quite important. They ask that a lot in the questions, and this will be the tangential or wheel component of the absolute flow velocity. The absolute flow velocity is V naught, or VO, should I say. This is the absolute flow velocity, and as you can see, this is a right angle triangle, so the tangential component will be VWO, and the radial component is VFO, okay? And so you must know that VFO is the radial component of the absolute flow velocity, and VWO is the tangential or wheel component of the absolute flow velocity. And x that you see here, if you just look at these dimensions, you will see that x is the difference between UO and VWO, because if you do UO minus VWO, this length minus that length, you get x. Remember, a velocity diagram is a way of graphically representing velocities in terms of length. And when you did power machines, you learned to use a specific scale to actually be able to draw these velocities. Okay, so it's going to be quite important for you to familiarize yourself with the velocity diagram of a centrifugal pump, and particularly the outlet triangle, because almost 100% of the questions that you will get, almost 100% of the questions you will get on the velocity diagram will be referring to the outlet triangle, outlet velocities, and also these angles.